Thank you. Entonces ahí say que you consider que A times X equal B. Bueno, look like similar, no? To this equation. Look, the problem is que this equation is one dimension and this is three dimensional. Okay, now you say you solving very, very similar. In the one dimensional piece, okay, you divide by 2 or multiply by 1/2. Both sides. And you know the 1/2 times 2 is 1, and 1 is invisible, by the way, and 4 times 1/2 is equivalent to divided by 2. The answer is 2, and that's it. I finish. This is my problem in 1D. We are doing similar, but I know que es a matrix, no one dimension. So now I recommend, in order to isolate the variable, que es capital X, que es 3 variable, 1, 2, 3, you pre-multiply this equation by the inverse matrix of A. So pre-multiply means multiply in the left by A inverse, because I suppose A matrix is invertible. I do another multiplication. In order to doesn't affect, you pre-multiply both sides by the inverse matrix of A. Okay, nice, it's legal. After that, I know very, very well that the multiplication two matrices and its inverse is the identity matrix. The same dimension, in this case, identity matrix dimension 3, no? In this example, but in general, base M times X equal A inverse times B. And you know also that the multiplication, the inverse matrix, the identity matrix, sorry, times X is exactly the same. So identity matrix working like a 1 multiplication by 1, que es invisible, no? But multiplication 3 equations simultaneous. So it's a big one, dimension 3, no? Es identity matrix. Pero no, the terminology que es using in matrix is identity. Therefore, is X equal the multiplication A inverse times B. Que es our famous formula. You apply that formula. So basically, the only thing you should do is you take the matrix 8, find the inverse matrix, and multiplication by vector B. And you obtain 1 vector 3 by 1, but this vector 3 by 1 is X, Y, and Z. And when you perform the multiplication, obviously, we get 3 numbers, no? 1 number, 2 number, 3 number. Therefore, X is equal to that number, Y is equal to that number, and Z is equal to that. Again, the story. Let's do it quickly. Of course, the long process is computing the inverse matrix. You see in the last lecture, but no. We are doing using GeoGebra, no? Of course. Okay. Let's move into the GeoGebra. Do you follow me? Do you understand the basic idea? Oh, sorry. Forget about the rest. The important thing now is that formula. The only limitation, the only limitation, Giselle, of the formula is que our original matrix is no invertible. Si es no invertible, entonces we are in big trouble. Well, in big trouble, no. In big trouble using this method, where we have another method. Okay, entonces remember, it's no invertible when the determinant is 0. It's like a singular. It's a technical name. That to have inverse, we need our matrix would be a square, 3 by 3, 4 by 4, 5 by 5, 2 by 2, and also non-singular. Okay, non-singular means, see, I put a negation here, non-singular means that this determinant is different to 0 to is invertible. Okay, no more blah blah blah. Let's move on to the GeoGebra. You let me know so you see my GeoGebra window. Switching to GeoGebra window. Do you see GeoGebra window? Yes or no? Now in any place in the spreadsheet. Are you familiar, no? With the GeoGebra window, right? Are you familiar? You practice a little bit or not yet? It's easy. It's easy. Yeah, Rebecca, I say, yeah, I'm familiar. Okay, so you type in any place the matrix A, que es 3 minus 2, 1, 1 again, 4, negative 1. Oh, negative, alone, no, negative 1, negative 1, negative 1, enter, 2, 5, negative 2, 2, 5, negative 2. Cool. I made 3A. Okay. I suppose I make a mistake in one place. Let me see. Delete that part. Yeah. It's negative 1, not good. Let me type it again. Negative 1. In this moment, I can do, why not, create a matrix associated. This is my A matrix. I want to rename like a matrix A. Rename matrix A. Capital. Okay, cool. I have that. Likewise, I type in the matrix B in any place. It doesn't matter. The matrix B is a vector because it's one dimension, 3 by 1. So at least one dimension is 1. It's called a vector. In this case, it's called a vector. It's 2, 6, and 6. Wow. Repetition 6. I select that, right click, create matrix. Okay, I rename like a B. Capital B. Okay. Now ready. You in CAS. That's another window. You are doing the multiplication, the inverse matrix of A. You remember, inverse matrix is you copy invert of the matrix, of course, not the function matrix. The matrix A, multiplication is as always in any computer and calculator. You press Shift 8. It's a period. It's a multiplication B. And you type B and you press now Enter to perform that operation. Bang! And the operation is 1, 2, 3. I create intentionally to funny value 1, 2, 3. So you see that the first component is x, so x is equal 1, y is equal 2, and z is equal 3. End the story. That's it. Any question? No problem. Clear, crystal clear. Let's move on. Super. Chain. Let's move it again to the whiteboard because I want to start the solution of the review package. Okay. Let me try to share the window. Okay, whiteboard, no. Okay, whiteboard now. Okay, I want to erase totally my whiteboard, new whiteboard. Okay, there you go. Do you see whiteboard, right? I want to copy the question one in the review package. Is X is a system. It's a system. But that system, you don't need to solve it. You only need to verify. And verify is different. Verify is is giving one hypothetical solution and you plug it in. If it's true in any equation, obviously it's a solution. Otherwise, no solution. Okay. This is equation 2. 3x plus y plus z equal to equation 3. This is my system. I need, in this problem, verify if the solution x equal 3, y equal 2, and z equal -1 is solution or no. The answer is yes or no. You are doing equation by equation. Equation 1. Equation 1 is this equation. You plug it in. Who is x? 3. Plus y. Who is y? 2. And who is z? -1. So plus -1 would be equal, I claim that 4. It's obviously true, right? Plus 3 plus 2 is 5. 5 minus 1 is 4. Okay, cool. Let's move on to equation 2. To be solution must be true in any equation. Entonces 3 again, minus 2, plus 5 times -1. Should be 12. Wow, entonces 3 minus 2 is 1 minus 5. And this is -4, I guess, or no, equal 12. Okay, this is 3 minus 2 is 1. And 1 minus 5 is -4. And -4, of course, is not equal 12. It's completely false statement. That means that this is no solution. No solution. So in the test, you can find one question similar to this, in which obviously you need to verify and verify. Entonces you see, bueno, professor, you can solve in the system and compare with the solution is given. Yeah, you can, but it's too long. So either way. So you solving and you compare, it's differently. So now there's no solution. It's solving. This solution is solution, but another system, not this system. Any question? Any question? Super clear?
If the equation has no solution, just write no solution.
Okay. The idea is, I don't know si this system have solution or no. But I know very well that this solution gets given don't belong to this system. Okay?
Okay, but for the question on the test, if the question has no solution, we just write no solution.
See, the answer is no solution. Yeah.
Okay.
Que es the option B in the handout. You have two answers, A or B, solution or no solution. Yeah, no solution. You verify and fail the verification. Okay, number 2 is also easy. Is the system is giving x plus 4y plus 2c equal 3, equation 1. 5y plus 3c equal 4, equation 2. And the last equation is super easy, is z equal -2. So this is the classical example in which the system is written like the echelon form. Echelon form. Echelon look like stairs, like that. Look, it's missing the x, it's missing the x and y, and I take advantage. So you solving using back substitution. Because I go to the last equation, and I know that c is negative. Cool. Now replace in the second equation back. You go backward. So 5y plus 3 times -2 should be 4. I plug it in, c equal -2, replace c for -2, in the equation number 2. So 5y minus 6 equal 4. 5y equal 4 plus 6 is 10. Divided by 5, everything, both sides, y2. Okay, now C is easy. Substitution, C negative 2 and y positive 2 into the first equation. So the only unknown that we have is x. So x, hello, you are late, guest user. X plus 4 times what? 2, no? Okay, y. Okay. Who are you? Identification, name. Plus 2 times negative 2, no? Equal 3. Okay, you replace in this equation that 2 here and that 2 here. Of course, the corresponding sign. Okay, so we have x plus 8 minus 4, no? Equal 3. 8 minus 4 is 4, positive 4. And x alone is equal to 3 minus 4 is negative 1. Aha, so what is my final answer? Well, my final answer is the solution for this system is the triplet order formed by the x, y, z. X is negative 1, y is positive 2, and z is negative 2. Que corresponde very well with the option A in our handout. Remember, in the test, we have no multiple choice. No, you only solving, and that's it. I want to see your word. No? So you put a final answer, and I don't see any word, 0 for you. I need to see the word. And detect. Yeah, in detecting, see you copy for another person. Because when you don't know very well, you write a stupid thing. Yeah, detect, he or she don't doing this. You copy for another person. And this affect the grade, of course. Any question? No problem so far? Question 1, question 2, 100 points in the test. Let's move on. No problem. Let's move on to question 3. And the question 3 is very weird. No question. The question 3 is very weird. Solve the system of the equation. You can change your name. Change your name. You can. No, I don't. I don't change. Never change my name. X plus y plus c. And the problem is, do you think I saying to link in the video the link of the lecture, the specification, to get inside the lecture, and another link is a software that we are using today, maybe today or Wednesday, I don't know. We use it. We are doing by hand or using this software. I want to explain. Okay, let's focus on the question 3, guys. X plus y plus c equal 10, equation 1. X minus y plus 3z equal 14. Equation 2, nice. And this is minus. And this is 2x plus 2y plus 2c equal to cool. This is my system. It's given in the problem. It's given in the test. I need to solve it. Okay. Entonces now, when you see that the question says if the system have no solution, say que es inconsistent. This is synonym. See, have no solution is inconsistent because the word inconsistent or the adjective inconsistent indicates no solution. Because I suspect it's something we are having in this problem. There are two different ways to do it. For the student que have a strong intuition, you take, for example, the third equation. I see something we are having. What is the reason that the professor put 2, 2, 2, and 12? Ah, because it's even number, right? Even, everything is even numbers. Entonces, I know very well que you can, if you want multiplication, no, divided by, you divide by 2, the entire equation 3, you obtain divided by 2, this is perfect legal, divided by 2, divided by 2, this is classical, this is like a row operation, and thus you have x plus y plus c equals 6, equals 12 divided by 26. And this equation is equivalent 100% of the original 3 that's given at the beginning. However, this is easier, in my opinion. But something we are, look, if you compare this equation and this equation, something is wrong, because x plus y plus c equals 10 and x plus y plus c is equal to 6, o es 10 o es 6, pero no. Do you see the contradiction? Do you see the contradiction? Entonces, what do you suppose to happen here? I don't know. Gladys, yes, I saw the contradiction. Entonces, what do you think? When you, in algebra, you try to solve in the system, and you get the contradiction. Contradiction is you get the totally untrue, so false statement. It's because we have no solution. Y si es no solution, it's inconsistent. Entonces the answer is inconsistent and end the story. Okay. This is for the student that have a strong intuition. Pero suppose que you have no strong intuition, okay, no problema. So now, you don't see that part. You don't see that part divided by 2. No, professor, why? Pero I know you explain me strong way to determine the solution of the system using matrix. Okay, I know very well that you set up the augmented matrix associated with the system. Okay, is in that case 1, 1, 1, the line 10, 1, negative 1, 3, 14, 2, 2, 2, 12. By the way, that matrix is dimension is 3 by 4. No, we have 3 row. It's obvious, it's logical, because we have 3 equations. The number of row is always coincident with the number of equations, and the number of columns is the same, plus 1, because you include inside the augmented matrix the connection A, line B. This augmented. Now we are ready to apply the famous reduced row echelon form. Of course, we are doing using GeoGebra, no? GeoGebra Classic. There are many ways, guys. There are software, another software. I like GeoGebra because it's easy. Can get in, and tributes can get in. No, why not? I don't understand why. I sent for everyone the link. Okay, so let's do it. I can get in. Gustavo. Okay. It's a complicated link today. Maybe you click in the wrong link. I think about that, but it's okay. Okay, let's do it. Entonces, en GeoGebra, let me try to share the screen of the GeoGebra. Okay, look. Okay, I have that. Algebra, I suppose you see algebra now or not yet? Easy. You delete that part, get another problem, new calculator, and you type in the augmented matrix. 1, 1, 10. 1, -1, 14, 2, okay, so this is the augmented matrix. I select everything, create the matrix. Okay, the matrix I don't want to rename, no? I use the same default name as M1. But this suck. No, not suck. Okay, now and now using no inverted matrix anymore, no determinant, no. Using reduce the row, reduce it, row echelon form of the matrix and more. And one. No capital. Because it doesn't matter, but just in case. Matrix 1. Press enter, bam, and you get that. Let me copy, let me make a screenshot of this idea. No, screenshot, no necessary. This was the time. Okay, I copy in one piece of paper. Yeah, I copy now in my whiteboard. Okay. Do you see the process, right? Classic. We practice a lot of this. Now I come back to the whiteboard. Okay, continuation. Yeah, I copy after the famous reducer row echelon for my new matrix. Okay, it is 1, 0, 2, 0. This is the line. We separate the coefficients in front of the variable and the right hand side. No? It's a 1, 1 again, sorry. 1, 1, 1, 1, -1, and 0. And the last equation is 0, 0, 0, and 1. And this is a moment in which you can see more clear now the contradiction, because the last equation is this. So you translate like a equation, no, like a matrix row, is 0x plus 0y plus 0z is equal 1. And 0 something variable is 0 equal 1. This is a contradiction. It's completely false. Therefore, no solution. No solution. Do you see, guys? Either way, intuition or no intuition, using software or no software. Okay? Any question? I need to make sure that you understand very well everything, guys. This is long package, I know, but we have today. Question. What part is confusing? And number 3. No? Sure? Okay. Let's move on to number 4 question. The 4 question is super easy. This is my gift in the test. Look. Okay, it's only write the augmented matrix for the given system. Of course, complicated, long, but you don't need to solve it. Only write. It's for practice a little bit the matrix language. No? Number 4, we have 4 equations. 1, 2, 3, 4. Yeah. The first equation is 3x plus 9y minus 5z plus w equal 5. This is my first equation. The second equation, something is missing. I want to copy arbitrarily. It's 6y plus c equal minus 2, equation 2. Something is missing. Of course, x is missing, y no, c is missing, w is missing. No, c is not missing, sorry. W is missing. The third equation is x minus y minus 10z, so no w. W is missing, equal minus 12. I organize, look, the equal sign guide me. After in the matrix you see more clear because now it's disorganized. The last equation is 12x minus 12y plus 2c equal 11. Equation 2. So our system contains 4 equations. Therefore, our matrix contains 4 rows. So the organization and matrix of this system is, you have 4 rows corresponding with 1 by 1 equation. And the number of columns, I don't know. One column is reserved by the x variable, y, z, and w. And after the right hand side is just a number. Right? Actually, my matrix is 4 by 5. 4 row, 5 column. No? This is the right hand side number. That number. Look. If you want, you copy directly here. 5 minus 2 minus 12 or 11. Oh no, you copy row by row, much better. Let's say 3 and 9 and negative 5 and 1. And this is my equation 1 expressed in matrix 4. And equation 2, be careful, because x is missing, no x, y is 6, c is 1, and w is 0, 2, 0. And the third equation is 1, negative 1, negative 10, and 0 again, no w, equal 12. I try to line out, guys, properly. So this is 12, this is minus 12, this is 2, no w also, equal 11. Boom! And this is my final answer. Okay, by the way, matching perfectly with the option B and the handout. That's it, don't do any more. Some students don't understand very well this question, doesn't put in the algebra and solve it. No. It's, the question says write the augmented matrix of the given system of equations. No solving. This is my div, and 20 questions. The value of my div is 5. Cool. Any question? No problema. I want to see your face. Nobody activate the camera. No problema. Clear. You say it's clear. Okay. Clear. I understand. It's easy. It's obviously clear. Okay, let's go to the. It's not too complicated, but it may be confusing. No? So we have in the question 5. In the question 5, we have one matrix S given. Let me copy 1 minus 3 minus 5, 2 minus 5, 2, 3 minus 5, 4. And it's a maintain matrix that you separate by the bar. Right hand side get 2, 5, and 6. Let me double checking. So I copy well or no. Yeah, I copy. By the way, the dimension is 3 by 4. Entonces, on that matrix, you need to perform several row operations. This indicates, entonces you respect. So the row operation number 1 is, row operation number 1 is R2 equal minus 2 R1 plus R2. So you are familiar, guys, with this notation. So now I call the original row gets given in the matrix. I call R1, R2, R3. However, I create a new one after the transformation. Okay, I call capital. Okay. Entonces I want to explain this by hand. Okay, and also I want to use the software I sent. So in the email I sent today, I sent another link. Because I want to show you. Maybe it's good or no. It's up to you. You let me know. You say no, I prefer by hand. Okay, no problem. However, it's good to double check it. So you will have time. You are doing by hand, cool. To say I want to check if my computation is okay or no. You put in the software, and the software. This is the only software online in which you can do the row operation one by one. Because the majority of software, let's do it directly the reduced row echelon, so totally the row operation that you need to for solving the system, but not one by one. So the detail one by one is only this. Let's do it. Okay, suppose we are doing the row operation number 1 on the original matrix. Okay, si I do this row operation number 1, es obvio que the row que participate in the game is row 1 and the row 2, because the formula indicates, no, row 1 and row 2. However, the row 2 is special because it's the row que change. So the only row que change is 2. Look here, 2. Entonces, once it change, that means que 1 and 3 stay the same. I copy 1, minus 3, minus 5, 6, 2. This participate, but don't change. 3, negative 5, 4, and 6 stay the same. Let's do it. So now I want to, if you want to see mentally or not necessarily mentally, in one piece of paper, this piece of paper, you write negative 4 times, because I want to do 4 operations, no? For each column, no? And you copy here the element of the entry of the row 1. Okay, is 1, minus 3, minus 5, and 2. Plus, I am using that formula, look, plus, this plus is this plus, row 2. Row 2, I don't know, I have no idea who is that. Oh no, yeah, it's the highlight in pink color, no? Okay, it's 2, negative 5, 2, and 5. And you perform one by one this operation. It's obvious that the first one is 0, no? Because 2, negative 2 times 1 is negative 2, negative 2 plus 2 is 0. Negative 2 times negative 3 is positive 6, and positive 6 minus 5 is 1. And negative 2 times negative 5 is positive 10, and 10 plus 2 is 12. And this is negative 2 times positive 2 is negative 4, plus 5 is 1. So you copy 0, 1, 12, and 1. Guy, do you follow me? You understand very well this or not? Yeah, Shane said, yes, I understand. Okay. But you need to do 3 operations. But that's easy because it's given. The important thing is okay, this is sequential. So you have the original matrix. It's that one. But you have the new one number 1. The second row operation, so row operation number 2, okay, I have to perform in this example is, let me try to see, is R3 is equal minus 3 R1 plus R3. Okay, obey this command. But it's obvious to understand, it's important to understand that this new row operation is doing all this matrix, and this is history channel. I don't care anymore the region. I perform this into the new one. Okay, entonces es antigui, and you update new number 2 and find new number 3, and this is find new number 3 is the finals. Row operation, sorry, number 2 is okay. So in this new row operation number 2 involve row 1 and row 3. So this row 1 and this row 3. Therefore, the answer that you obtain when you finish your storage in row 3. So the only row that actually change is row 3. Therefore, row 1 participate in the game, but don't change. And row 2 not participate in the game, of course doesn't change. Now row 3 only change. So negative 3, negative 3, negative 3, negative 3. I copy the element. Remember the format for the row operation is we have factor. Factor is just a number, real number. Row pivot and row, let me call storage, something like that. This is my interpretation. We have 3 elements in the row operation. We have the factor, we have the row pivot. In this case, the row pivot is the 1, and we have the row storage, case 3. Okay, so I copy 1 minus 3 minus 5 and 2, no? So, wow, it's the same of this, except in this first example the factor was 2. Now the factor is 3, or minus 3, sorry. Plus the row 3. The row 3 original. Not original at the beginning, you know, the new. In order to obtain new number 2. So you copy the row 3 of the new number 1. Okay, 3, negative 5, positive 4, and 6. Okay, this is 0. Equal negative 3 and positive 3 is 0. This is 9, positive, minus 5, 4. F4. All right, 0, 4, yeah. This is 3 times 5, 15, but positive 15, plus 4, 19. And this is minus 6 is 0 again. Plus 6 is 0. And my new matrix number 2 is 0, 4, 0, 4, 19, and 0. And that's it, I finish. No, I need to perform 3 operations. So far, everyone follow me or no? All right, all good, all good. Chain is all good. Okay, entonces let's do in the row operation number 3. I want to copy the equation that's given 5 R2. You said yes. Plus R3. But I forgot something important. And storage and R3. Doesn't matter the order. No? So R3 capital storage is equal 5 multiplication 5 the factor of 5. The row P was 2 and the row storage is 3. Okay. Entonces now I have to perform the row operation number 3. I saw clear. I saw the only row that changed is 3. And 1 stays the same. And 2 stay the same. Don't forget the line. And 3 change. This is the factor 5. 5, 5, 5, 4, 5. Multiplication by the row pivot. In this case, the 2. And the 2 is 0, 1, 12, and 1. That number. 0, 1, 12, 1. Plus the corresponding in the same position of the row 3, of course, of this guy, no? Is 0, is 4, is 19, and this is 0. Okay, so we have 0, 5 times 0 is 0, plus 0 is 0, 1 times 5, 5 plus 4 is 9. Entonces, bueno, this is complicated, but we're using the calculator. I put 12, well, 12 times 5 is 60. And 60 plus 19 is 79. Wow, easy. Not necessary calculator. And 5 times 1 is 5, plus 0 is 5. Okay, so my final answer is 0, 9, 79, and 5. Okay, by the way, is the option B. Does everyone follow me? All right. Yeah. Okay. I want to illustrate at least, because we have the question 5, the question 6, and the question 7. Okay, similar, the same stupid thing. I don't know si unique. I continue. Si you consider that I am doing, but no, I suppose it's not necessary. And just I want to spend the time to are doing exactly the same problem, but using the software. The software I sent to you is the linear algebra tools. Let me try to share the window. Switching to that one, linear algebra tools kit. Okay, let me see. You see linear algebra toolkit? You see or not? All right. Yes. Okay. Good. So now let's do it. In this case, you have number of rows. Well, number of rows is 3, no? We have 3 rows. Number of column is 4. One more. And press submit. You open, of course, 12 window or 12 text box to type in any number that we need in the matrix. This is the matrix editor. 1, -3, using my keyboard, -3, -5, 2, 2 positive, -5, 2, 3, -5 again, and 4. Finally, 6. Okay, this is my matrix. Let me verification, see everything is okay or no. Yeah, I guess. Yeah. So say I submit, and you have my matrix, and you see the matrix here. Initial matrix is the technical name. So now we have different buttons doing what? The different row operations that we can do in the matrix. Remember, we have the row operation in which you multiply by a factor and adding with another row. Interchange the row. Multiply, just multiply. It's easy. But now in this case, complicated. So now you need to declare in the first matrix the factor. The factor I can see is -2. You put -2 here. Bam. Entonces you declare what is the pivot row is the row 1, the first. And what is the storage row 2. And you do it. Press do it. Bam. And you see in yellow color our new matrix. Okay, in yellow color you see after the first row operation. Okay, and you continue doing, Let's do in the second. The second is, well, the second row operation is the factor is the -3, -3 is the factor. The row pivot again is row 1, but the storage row now is 3. Do it. Bam. And you know, magical happen. Okay, the new number 1 now is switching. In yellow you see the actual new. Okay, is 101 12 1. Wow, cool. 04 19 0. And you put it in red color the row change. Okay. Finally, let's do in the last one, the factor of 5. The factor of 5. And 5 multiplied by row 2. Now the pivot is now in row 2. The storage row is in 3, no? 3. Do it. Bam! And my final answer is 1, -3, -5, 2, 0. And remember the last row can change. The row 3 is 0, 9, 79, and 5. Super cool. Do you see, guys? Yes. Okay. My question now is, you consider necessary repetition 6 and 7 is the same stupid thing or no? So you say yes, I repeat. No. Of course, no, it's the same. And you verify. So you verify in this row operation calculator. Super. It was worth the time to explain in this. Yeah, I go directly to question 8. No more linear algebra toolkit. From now we are using GeoGebra. I don't know. Okay, let me come back again to the whiteboard. Whiteboard. Let me erase all my whiteboard. Okay, let's move on to the question 8. Okay, question 8 is, well, minus 2x minus y minus 6z equal minus 77. Wow, too many negatives in this equation. You can change this out. Of course you can. Multiply by -1, and that's it. But okay. Negative 7x. Y is missing in this equation. Plus 3z equal minus 29. Equation 2. And the last equation is 9y positive plus c, 1c positive equal 72. Equation 3. This is my system. Entonces now, okay, do it by hand is not crazy, but it's a long process. Any problem, this is the rule. Any problem in 3 dimensions, more than 3 dimensions, 4 dimensions, we are doing by GeoGebra. So the problem in 2 dimensions by hand. Okay, can you see in the test problem in 2 dimensions by hand? Now, of course, you can verify in GeoGebra, but in this case, solve 3 dimensions, professor. Entonces now you copy -2, -1, -6, -7. -7, 0y, 3z, minus 29, 0x, 69, 1, and 72. This is my augmented matrix with the dimension is 3 by 4. And you apply. The question said, solve the system of equations using matrices. Row operation, pero no one by one, sino totally. So in this operation, reduce a row echelon form, you are doing the enough row operation to express it, the answer in echelon reduce. Okay, it's like using Gauss-Jordan method, no? And you see, in this case, you see in the main diagonal just 1, and after the 1, below and above just 0. Here the right hand side, we have the solution that is 8, 7, and 9. Now I want to do for you in the GeoGebra now. Entonces, this is classical example in which you have here the identity matrix dimension 3, nice, no free variable, unique solution, only one solution, and it's obvious that x is equal 8, y is equal 7, and z is equal 9. And the story, que es the solution, the option A, in the handout. Because I have a question, no? You consider it necessary to repeat again the process in GeoGebra of this or no? Let me know. So you consider it necessary, I repeat, no problem. All right? No, it's okay. You say no, it's okay. Everyone is agree, guy? You are strong in GeoGebra. Cool. So we focus on the most important, is the interpretation. The problem, no? Interpretation. One more example. One more similar. So in the test you have several, okay, you are using the first method that we studied, que es reduce a row echelon. Suppose this example, ax minus 7y plus 3z equal minus 122. Equation 1. Minus 40 x plus 35 y minus 15z equal 610. Equation 2. Don't be scared with the number because the software manipulates this perfectly. The last equation is 16x minus 14y plus 6z equal minus 244. Okay. The word is you typing everything in the matrix editor. You create the matrix and you perform. So let's do it. Let's do it by hand. At least the thing I want to do in the test is this. You copy matrix A minus 7, 3 bar minus 122, minus 40, plus 35, not necessarily plus, below 35, I suppose default get positive, minus 15, 6, 10, 16, negative 14, 6, and minus 244. This is the matrix, get 3 by 4 again. And you apply the famous reduce row echelon form. And this specific example is magic. Look at what happened. And I need help to interpretation this. You have one, you have in the X column. By the way, this is the X column, Y column, Z column, right hand side numbers. In the X we have 1 minus 7 over 8 fraction. Wow, Y. C is 3 over 8. And the right hand side in the first equation is minus 61 over 4. This is the right hand side. And amazing, look at what happened in the other equation. 0, 0, 0, 0, 0, 0, 0, and 0. Wow. What is that? What is the interpretation of that? I need help to understand this. What do you think happened? What happened with the second equation and the third equation? Our opinion. We dedicate time in the important part. The mechanical part is not important. But the important part is the interpretation, yes. When you see 0, 0 is nothing, no? So we can delete this or no? You can use eraser and delete that part, yes or no? Actually, this matrix you have now is 1 by 4, no? So what happened with this equation and this equation? Well, this equation and this equation, 2 and 3, are so elimination process. Discover are depending equation. And so you take a look a little bit, you see, for example, if you multiply, let me try to explain this. If you multiply the equation 1 by negative 5, you have 8 times negative 5 is negative 40, 7 times negative 5 positive 35, and negative 5 times 3 is 15, and 122 negative times 5 is 610. You can verify with the calculator. Likewise, at the beginning I don't see, of course. If you multiply, for example, the equation 1 again by 2, positive is 16, negative 14, 6, and 122 times 2 is 244. So the equation 2 and 3 are the same plane, because in 3D each equation is a plane. So actually we have no 3 plane, we have only 1 plane, because the plane 2 and the plane 3 is the same plane. Wow. Entonces es obvio que we have infinity many solutions, no? But this is not the point. The point is how many free variables you believe can we have in this case, and how you represent algebraically the solution set. Okay, by the way, is the plane, I guess so, no? Que exists in 3-dimensional context. How many free variables you believe can we have? How many free? No idea? Nobody lost, totally lost? You try. Maybe if you make a mistake, no problem. Do you understand very well free variable? So you see, we have no free variable, zero free variable. It's because we have unique solution. But in this case, no, because we have equations that are depending of the other equation. And elimination process discover that fact and delete this equation. And I have only one that, by the way, is the same. You see. Entonces now infinity many solution. Are you agree que es infinity many solution? Everyone follow me so far? Yes or no? Say something. You are sleeping. Come on.
Yes,
Sydney.
yes.
Okay. You seek infinity many, right? Maybe the complicated part is how many free variables. Because when it's infinity many solution, for sure we have free variables. To visualize the amount of free variable and the amount of the variable that is not free, remember we focus in the identity matrix, and the typical format is suppose 2D 1 0 0 1 2 3 4 5 6 7, and I discover in another example, not in this, the situation. This is elimination. We focus in the identity matrix. The variable associated with the identity matrix, by the way, in this case, dimension 2, is x and y. So x and y are non-free. And the only free is this, que es z and w. Okay, actually, so now, in order to express it, the solution, you express it, the x and y is not free as a function of c and w. Okay, by the way, c and w are free. C and w are free. There. And free means, or remember, because in this case we have no identity matrix dimension 2. No. Because we have only one here. Therefore, we can interpret it like identity matrix dimension 1. It's like a scalar. And the extra block of the free variable is this and this. The conclusion so far is y and z are free. And it's logical because we need two free variables, because our solution set is represented like a plane. Any point on the plane is solution. How you express that? Easy. You copy the first equation, that by the way is x minus 7 over 8y plus 3 over 8z equal minus 61 over 4. And you solve for the non-free variable. This is x alone is equal minus 61 over 4 plus 7 over 8y plus minus 3 over 8z. Now remember, you write like that. This is one place for the x, comma, one place for the y, comma, one place for the z, and close the brackets. What is the place of the x? The place of the x, you copy this expression here. Let's do it formally, no? It's minus 61 over 4 plus 7 over 8y minus 3 over 8z. I finish, comma, this comma is this comma, and y is free. I copy y, and z is free. I copy z. And the specification is one, y and z are any real numbers. Free variable is synonym to C free. Therefore, our solution set contains two free variables because this set is a plane in 3D. It's a plane living in 3 dimension context 3D, It's the classical three-dimensional space, X, Y, Z. However, this plane, I don't want to graphic the plane. This is more complicated. Calculus 3. It's a plane. This is another problem. The graphic is another problem. The algebra is relative. Guys, do you understand very well this or not? No, opinion. This is a moment to discussing. Yep. Shane is a yep, bro. Shane is a genius. The regular students. Do you understand very well the idea behind free variable? Definitely it's the last time we see that after the test. Do you understand very well? Opinion. I want to hear opinion. Benjamin, Jonathan, Leila, Daniel, Michael, Samiha, Janice, Sumondre, Giselle understand everything good. Fernando, David, Sidney. No problema.
Yes.
Cool. Let's move on to another problem. I propose to get the last one because you have time. So stop. You enjoy your holiday. I will. Wednesday we continue the review part. Okay. We are doing now number 11. 11 problem. And you help me now a little bit. Okay. Let me try. Let me erase everything in my whiteboard. I want to copy example 11. Example 11 say 11 5x plus y equal 1. This is my equation 1. 2x minus y plus z minus w equal 3. Equation 2. C plus W equal 7. Equation 3. Wow, what the hell is that? I don't understand very well. Okay, how many equations we have in that problem? We have 3. How many unknown we have in this problem? We have X, Y, Z, and W. 4. 4 and 3. Oh, professor, this system is underdetermined. Because to be perfect determinant, we need one more equation. No? In order to get 4 equations, 4 unknown. And maybe see we have full determinant for maybe, not always. If you suppose that every equation are independent, linear independent, so you have unique solution. Entonces es obvio que this system que we have, lack of information, we need more information, is underdetermined. We have no unique solution anymore. No. We have infinity many solutions or no solution. I have no idea. But you understand very well logically que we have no unique solution. Es obvio que no. Actually, yeah, Giselle. Okay, cool. The only possibility to have unique solution is que my system would be determinants at the same amount of the unknown and the same amount, and the equation are linear independent. See the equation, do you see the example number 9? Okay, at the beginning you suppose we have 3 equations, but no, we have no 3 equations. We have only 1 equation because I discovered in the middle of the process that the equation 2 and 3 and the number 9 are dependent. So now fail the condition for unique solution. Okay, no problem. I understand. The goal is, fortunately, we can analyze systematically this idea using the matrix. The matrix magic. Now I set out the matrix. The matrix, remember, we have X, column, Y column, C column, W column. And you put the right hand side. One more time, we use augmented matrix today. And the first row is 5, 1, 0, 0, 1. This is my first equation. The second is 2, negative 1, 1, negative 1, 3. Cool. And the last one is no x, no y, 1c, 1w, and 7. This is the matrix. By the way, 3 by 5. No, I guess so. Let me see. 1, 2, 3, 1, 2, 3, 4, 5. Yeah, 3 by 5. And the dimension of that. Okay. So I don't have idea. My intuition don't see too much beyond this idea. I use my famous reducer row echelon, of course, in GeoGebra right now. Yeah, I determine what's going on. I anticipate the answer. No, the answer is X, Y, C, W, right hand side. Okay, is 1, is 0, is 0, is negative 2 over 7. This is negative 3 over 7. This is my first equation after they apply the procedure Gauss-Jordan, no? Reduce the row echelon. And express it in reduced row echelon form. And the second equation is 0, 1, 0, 10 over 7, fractions, and 22 over 7. And the last equation is 0, 0, 1, 1, and 7. I suppose that the last equation doesn't change. It stays the same. Look, this is the same of this. And no more, any more I can do. This is the minimum expression. Okay, now analysis. Analysis. What do you think? Remember, at the beginning, theoretically, I predict that we have no unique solution. And you see, one of professor, no unique solution. However, I can see clear like water this identity matrix dimension 3. That means that the x, y, and z are non-free variable. Pero entonces, ¿cuál es the free? Es obvio que the free es the extra block totally independent of the identity matrix dimension 3. This is the identity matrix dimension 3. 3 by 3, 9. Okay, entonces W es free. W es free. W es free. W I declaré like a free. Only one. See, we have only one free variable. It's because the solution set when I finish the problem is one dimension. So basically, see, I try to interpret algebraically this solution is a line because there's one free variable, one dimension, but this line is living in the 4-dimension context. Okay, of course, 4 dimension is impossible represent graphically. So the only possibility to do graphical is to only 3 dimensions. So the classical 1 dimension, 2 dimension, 3 dimension, and stop. No more geometric representation, but exists like a hyperline or hyperplane. Okay, but nobody saw in your life, but everyone called using the hyperplane when it's 2 free verbs. A hyperline is a line que I suppose que es flat, no curvy, pero I don't know exactly because nobody saw in your life. Okay, so now I immediately, I don't waste the time, I write the first equation. I convert from the matrix language to the equation, que es X, no Y, no Z, no, and W, yes, pero es minus. Es minus 2 over 7W equal negative 3 over 7. As always, guys, you isolate the X part. Remember, the idea is express the non-free variable as a function of free variable. This is minus 3 over 7 plus 2 over 7. Bam. I have my first equation. Can you see? The second is no X, 1Y plus 10 over 7W again, because W, remember, is the only free variable, equal 22 over 7. Therefore, Y alone is 22 over 7 minus 10 over 7W. Okay, and the last equation, no X, no Y, only Z, only one Z, plus W equals 7. By the way, it's the same equation at the beginning. This equation and this is identical, but I need to write differently. I write like a C equals 7 minus 1. Equation 2 and equation 3. And I am ready to represent solution set. The solution set, as always, is the component that is X, comma, Y, comma, Z, comma, W. Who is X? In the place of X, I write this, que es minus 3 over 7 plus 2 over 7 W, comma, this comma is this comma, Y is this expression, is 22 over 7 minus 10 over 7 W, comma, and C plate is 7 minus W, comma, and who is W? W is W, because W is any real number. Es obvio, guys, it's obvious. Okay, matrix language guide me super fantastic clear to see the equation. In the chapter 2, when you do not study that part, we can manipulate, because actually not necessarily W is free. You can declare C free, so at least one. But the equation change because you declare Z like a free, entonces you manipulate the equation in order to express the rest of the variable X, Y, and W also as a function of the C that you declare. So there are no one strictly unique way to express an infinity many solution, no? So the most important is that you understand that we have one free and you express the other variable as a function of the free. Okay? Okay? So now stop. No more, because we almost are in holiday. We continue Wednesday for the I have a question on Alex. Okay, the question of the Alex. Remember, you send me a screenshot in my email, and I try to help you. I say the exam is. So my plan is, I don't know if it's online or not. Let me check it just in case now. Let me try take a calendar. Today is 3. 3 plus 7 is 10. So next Monday. Okay, next Monday is July 10. Es due the test written test. I sent today. Just in case I want to analyze or see now, see if the same day get due. Si es the same, si es not the same, I can move. Get the same, si es after, I suppose it's better, no? Right? Any question you have about homeworks? No, the test I cannot help, of course. Any question you have about the homework? You email me. It's my pleasure. I enjoy doing that. I try to solve it for you. I send the solution by email because I make another screenshot in my whiteboard, and you receive. Everyone understand very well.
Several question.
Uh-huh.
The Alex says that it's due Wednesday. Is that the proper date? Or is it
No, it's due Wednesday, no? That this Wednesday?
Yeah, it says that it's
No,
Wednesday.
no, I want to change right now to the same day, July 10th. Okay?
Okay.
Super. Thank you. Okay, thank you so much. Bye-bye. Wednesday we continue. Bye.